Aatif, why don't you
Tim,
introduce yourself and what you do on the Filecoin Forest team?
I'm an engineer on Forest, which is Filecoin implementation in Rust. We're trying to cover some use cases that, for example, Lotus might not cover so well. Part of what makes the internet free is the fact that you have a few different web browsers. It's not a monopoly where one implementation controls things. And what the folks over at Filecoin want to do is create an ecosystem like that for Filecoin.
So obviously, to be a proper internet sleuth slash interviewer, you know I had to do a bit of due diligence on you. Brother, it says here on LinkedIn, you were seriously studying medicine. And not only that, seriously involved in the practice of pediatric medicine. And then somehow you ended up at Microsoft as a software engineer before advancing on to Kraken, the crypto exchange, and then now ChainSafe. That is some serious wackadoodly career progression. What's your story with medicine? How did you end up in tech after that? And then how in the world did you end up in the degen world of crypto and no less niche world of Rust engineering?
I started studying medicine. I was at uni for about 4 years or so. I was never actually a doctor. Enjoying med school, but didn't really see it as the life for me. So I quit, got a job as a software engineer. I was enjoying my job at Microsoft, but I felt a little creatively stifled. I think a lot of crypto projects, they tend to have very engineering, creativity-led teams. Got into the space, and here I am now.
There's a lot of people at ChainSafe that has followed your career path somewhat similarly, where they were studying something, they didn't like it, and then they dropped out and then became a software engineer. Did you teach yourself software engineering?
My first employer, they didn't really care if you had any experience in software engineering. What they wanted was, can you do the problem solving? Can you sit down on an interview, get a pen and paper and explain your reasoning? And because ultimately that's what programming is. Personally, I have a quest against this kind of mysticism associated with our profession. We write scripts, we tell stories. It just so happens that the main thing we tell stories about is procedures. Yeah, once you have a little bit of professional experience, then it's not so hard to move between roles.
Nice. Well, like we're glad to have you here, and we're definitely glad to have you on the Forest team. I understand the Forest team wanted you here to take us deep into the technical weeds of the Rust client for the Filecoin network. I know that you were instrumental in helping the team complete their work on Forest's CAR files. From my limited understanding, the snapshots of the Filecoin network are stored as CAR files. But for Luddites like me, could you explain what snapshots are, why they are needed on the Filecoin network, why are they stored as CAR files?
Why don't I hop over onto a screen share and then we can talk a little bit more about what a snapshot is. Filecoin, like many things in the space, is like a blockchain. We have our blocks and they're forming a chain over into history. The blocks are made up of messages. For example, this message might say, Tim sends me one Phil, which is the currency of the Filecoin blockchain. So you've got this history of messages. There are two ways you consume these messages. You're either a Filecoin node, like Lotus, for example, and these messages are just like coming in from the network. You might take these messages and store them in a big database. And like most things in Filecoin, messages can be addressed by a content identifier, CID. This is like your standard paradigm. But what if you are trying to do something else? You're not just a node sitting on the network trying to catch up with messages. You can have a different way of consuming messages, which is that someone else very kindly, like Lotus, for example, takes all the messages they've seen and they put them in a big list like that. And so this just contains all those messages. And this would be a snapshot. All the messages I've seen up to this point in time. And we call those CAR files. Why is this useful? Suppose you're like a storage provider and you want to have a look at like the history of the blockchain or some specific time, and you want to understand the market, understand what kind of product you need to offer to be able to sell storage to people or something like that. Then this kind of use case is going to be very interesting for you. Another reason you might want a snapshot file is like you're just starting up a new Forest node, for example, and you want to catch up with the network has produced like 300,000 blocks or whatever. Well, it's probably more like 30,000. And you want to get like just the latest few of those blocks so that you can start keep on top of the messages people are sending. One of the jobs of a Filecoin node implementation is to take a message and execute it for yourself to check Tim's balance is currently like 2 Phils. He for sure has enough money to send some to Aatif here. So that's what a snapshot file is. What's the difference between blocks and the state of the network? So to disambiguate that a little bit, you have your messages. Tim sends money to me, or I agree to store 1 gigabyte for you. something like that. These are all messages, and these are, verified according to your traditional blockchain mechanisms. People reach some kind of consensus about them. But then you've got the state of the world, and this is stuff like your wallet balances and your like ongoing deals. Now, snapshots will always contain some messages, but they will also typically contain some data structures which relate to the state of the world. Naturally, this will involve wallets. It'll also store like lists of proofs and deals and stuff like that. Now, you can't store the entire state of the blockchain. You could, but it's currently like 32 terabytes. So what snapshots tend to do is they tend to have a little bit of information, the so-called block headers, for the entire chain. They'll have much more detailed information about recent messages. So these are the blocks, the actual messages. So they'll be like the most recent, say 2000 epochs. And they will store as much of this state as is required for those 2000 messages. Suppose I have a message that refers to some bit of data that refers to some other bit of data here, and they build this kind of like tree that reaches into the past. You'll typically have a portion of that data. There are a few different kinds of snapshots. What I've just described is a so-called light snapshot. If you wanted everything, that would be a full snapshot. You can also get things like diff snapshots, which don't reach into the past like this, but otherwise contain all the information. And I suppose that leads us on to some work that Forest recently did to make CAR files better. If you're a node like Lotus or Forest, if you're consuming a CAR file, you might be tempted to take each message and just feed it in and pretend it's like a message from the network. But this can be really slow. For example, Forest, when it receives messages from the network, it'll put them in a database. Why do we stick them in the database? We want to be able to look up messages later. Tim might send me some money, but I have to like look up messages about what Tim has previously sent to whom. I'll do that by storing that in the database. And remember, we look at messages by content ID. And your database is basically a big file on your disk. But what David, our tech lead, noticed is that we kind of already have that information on disk. It's in the CAR file. The CAR file is this paired listing of CID to message, and it's just got the past like 2000 messages. Why are we doing all the work of duplicating that data into our database? So this is bad for disk space. For context, for mainnet, we've got this like 50 gigabytes of compressed snapshot data, which is 100 gigabytes uncompressed. So for every snapshot, you're talking about a non-trivial amount of data, especially if you're looking far into the past, like every slice of time, you're like 100 gigs. And it's like, oh man. And then as soon as you put it into your database, you're basically using 150 gigs for data that you already have that's only 50 gigs. And then plus like it takes ages to load stuff into a database. When you're talking about thousands of messages, then you're spending a non-trivial time, especially at startup, trying to load your snapshot. David's insight was, surely we have the file here. Can we like skip the database altogether? Can we just go straight to the point in the file and say, oh yeah, the message you were looking for lives here? Just read that. So that's what we started doing in Forest. It's been really successful for us. The first way we approached this was using the uncompressed snapshot. So this would be 100 gigabytes. And just to talk about compression, you'll often get like snapshot.car.zst. So this is basically like a zip file, just like compressing the snapshot down. So we started off with an uncompressed snapshot, which is normally just snapshot.car. And we found we were able to get really good performance doing this. And it saved us all the time of like loading it into a database. And then we were able to make some tweaks to how the snapshots are actually stored to get that compression back. So now this might be like 53 gigabytes instead of 100. Not quite as low as a standard compressed snapshot, but importantly, you can use this kind of snapshot file with other Filecoin projects like Lotus. And Lotus won't know that this is a special portable database that is optimized for speed. That's what we did for snapshot files in Forest. Since then, the team's been working on improving this. For example, like Hailong, someone else on the team, made it so that you can read the files even faster by doing something called like memory mapping. Roman, someone else, has been working on, can you just read the same snapshot file from 100 different parts of the program at the same time and get optimum performance like that? One of the goals for Forest is to be able to take snapshot files like this and validate the entire blockchain history. So that 32 terabytes stretching back to 2018. Can we validate all of that? And it's only because we have developed this new way of handling snapshot that that's even feasible. You can't put that much data into a database. It would be incredibly painful. Whereas with Forest, we we have been able to store the entire blockchain on a single machine using commodity hardware, which we're really excited about and helps us push our product forwards and the Filecoin ecosystem forwards.
That's incredible to hear. So you're saying even these snapshot files that the Forest team worked on can be loaded into Lotus or like other Filecoin implementations?
Yeah, I mean, to draw the web analogy, you want to be able to use the same HTML file across web browsers. Like, that's the sign of a healthy system. If you've only got, you need the AOL program to load this particular part of the internet, then...
Don't remind me of that.
Yeah,
Right.
That's not a healthy ecosystem. So it was a priority for us that Lotus wouldn't be able to tell this is a special forest file. But if we know it's a special forest file, then we can take this shortcut and skip loading it into our database and just be that much quicker. So yeah, but backwards compatibility was really important for us. So just to elaborate, what Forest can now do is take multiple snapshot files and treat them all as one database. Like, you no longer have to do this thing where you have to take all these different snapshot files and load them one by one. It'll take tens of minutes to load a single file. Now you just give it a load of files and it will treat them as one store of blocks. And then you can just like index into them. And that's what makes it feasible for us to index the whole blockchain. We've even begun serving that for our own archival node.
That seems like an incredible public good in terms of like contribution to the ecosystem.
We just thought this kind of thing should be available. For us as software engineers, this is really useful because we want to test the entire blockchain. Can we execute every message in the history as we think it should be? As far as we know, no one else is checking the integrity of your blockchain, which is having something be publicly verifiable. And that's part of how you build like a decentralized trust. Another thing Forest recently did was taking this history of the blockchain. Previously, that was only really available commercially. If you wanted like the clean history of all your blocks going back to Genesis, then you needed to pay for that. And we were like, oh, we are going to host that for free, publish it for free, and we're gonna write our own archival node that can serve this for free. And it helps us be better software engineers because now we just have a bunch of data we can test. Like, I can write a test. What happens if this thing that happened 5 years ago and this caused a crash, does that still cause a crash?
How has it been received by like the Filecoin ecosystem? Like, are people excited about it? Are people already using it?
Yeah, I mean, so we've currently got a beta program out right now for our Forest archival node. At the time of recording, our product manager, Lee, is writing some release notes and getting our website up and running. So yeah, I think there is a bit of excitement about this from third parties interested in using this data. And David, who I've mentioned before, was with Hubert, another one of our excellent engineers in Iceland, and they were talking about this feature. Certainly the stuff about this more specialized snapshot file, like, generated some excitement and engagement. And we are keen for other implementations to be able to use our snapshot file. They give you the random access performance, but also the compression.
And so is this the end of the road for CAR files, or like are there further enhancements to be made?
Oh, for sure, there are further enhancements. Right now, I'm working on being able to merge the indexes for all these CAR files. One of the ways our snapshot works is it has an index at the back. If you're looking for this CID, go to this location in the file and it'll be there. Can you merge indexes like that together and index more data that way? Like I said before, we're looking at reading that data from a bunch of concurrent threads so that we can start to validate the blockchain. And that's something we're going to be doing over the next couple of quarters. Is we're going to start going to like random points in history and start executing messages and just checking that everything's as expected. We match Lotus's behavior. We're happy that there are no bugs. We deal with network upgrades correctly, just ensuring correctness, basically.
I want to give this time to you now to plug anything you want. Do you want people using your Forest nodes?
Come join the beta program if you're interested in like looking at the history of Filecoin. Come check out Forest on GitHub. I feel passionately about getting our code base hackable, well documented. If you're able to come and be able to read our code, come ask us questions. Maybe you've got exciting features or technical limitations. Like, think back to what David was thinking with the snapshot files and loading them into a database. It's like, oh man, we already have that information. Isn't there a better way? If you've got ideas like that, then get involved and we can help make them a reality. Check out our blog post. Start us on GitHub.